This is the third video for the 6-1F lesson, which covers the last part of this lesson, which includes something that is known as rationalizing the denominator. That if we had an example like number 14, which is 1 over root 5, this currently looks simplified. 1 is rational, doesn't have a square root, and root 5 is a prime number, so that's a dead end, and there aren't any perfect squares aside from one that go into that. However, from now on in the instructions or just understood is the fact that we have to do something which is known as rationalizing the expression or rationalizing the denominator or making the denominator a rational number, which means that we have to get rid of the square root. And what we're allowed to do here is, first of all, this is an expression, so we can't clear it. But what we can do is we can multiply it by something that is equal to 1. This is what we do when we have, let's say, 1/3. When we want to get a common denominator, we do something like this, which is we make it into 2/6 because we multiply the top and bottom by 2, and 2 over 2 is technically 1. So this is just changing the appearance of the fraction, but it's equivalent to what it started with. We're going to do the same thing here, but we're going to pick something, and that something is always going to be the irrational part of the denominator to multiply the top and bottom by. 1 times root 5 is just root 5. And root 5 times root 5 is, well, we can do it the long way, but usually we start to see that this isn't necessary, is root 25, which is just 5. And so we actually have a pair here, essentially, where one of them comes out. So we generally don't need to show this middle step here, but just as to convince ourselves this first time, this is why we chose this. We also didn't cancel here because it probably would have sent us back to where we started, where the answer was not simplified. And believe it or not, this is fully simplified. Even if you think the previous answer looked better, this one's considered simplified because the denominator is now a rational number, does not have a square root. We're going to try this a couple more times. I'm going to pick one that has a variable. So let's look at B. So currently, there's no simplifying that can be done. This is a dead-end problem currently. 6a is done. Square root of 3a is simplified and done. So I'm now going to multiply the top and bottom by the irrational part of the denominator. And so now I have 6a root 3a over 3a. So now this is rational because this would be 9a squared. And I'm now going to simplify. This was one of the things I talked about in the first video, is that if these are both out of the square root, I'm allowed to do this. These all cancel to ones, and this is going to be a 2. So our final answer, actually in this case, does clean up to at least look nicer, is 2 root 3a, 2 times the square root of 3a. And then we're going to look at one more, and even if you think you got this, you might want to listen to just this recommendation, which is on 17. Before you go about rationalizing, I personally think that it's usually better to try to simplify this and then rationalize. So you can do this. It's just if you're starting to notice you're getting a huge mess and it's getting nowhere closer to what the answer is on an answer key, then you might go back a step and focus on first simplifying this. So, for example, first of all, maybe this actually rationalizes itself somehow. This is a 10. Okay, it doesn't actually rationalize itself. It still has a root 3. Next thing I'm going to do is I'm going to cancel these because that's fair game and allowed. You could wait to do that. And you can see how now the rationalizing process is still will happen, but is a little bit cleaner and neater because I did the messier work kind of at the beginning and breaking up 300. And now when I rationalize, I'm going to only multiply by the irrational part. If I use a 5 in front of these, I'll just have more work as far as simplifying. So it's best just to use the irrational part. And so we have then root 3, 1 times root 3 is root 3, over 5 times 3. because square root of 9 will be 3. And our final answer is root 3 over 15, which is simplified. Root 3 is a dead end. There's no pairs in there. And the denominator has now been rationalized. It's a rational number. It is no longer irrational. And we're not going to cancel these because one is in the radical and the other one is out.